this video, we'll talk about polar coordinates and specifically for parabolas. And we'll do that by solving a problem. Let r equals 3 over 2 minus 2 sine of theta. Let's do first find e. So let's find the eccentricity. So how do we do that? Well, first of all, we rewrite the equation and we multiply it by the reciprocal of whatever value we have here. So we multiply top and bottom by 1/2. So when we do that, the numerator becomes 3 over 2 and the denominator is 1 minus sine theta. The reason why we do that is so that the denominator is now written in the standard form. So it's easier for us to identify that e is 1 because e is the coefficient in front of the trigonometric function. And because of that, we know that the equation that we started with, this equation, is the equation of a parabola. So the conic that we are dealing with is a parabola. Part 2. Let's find d. So we know that dE is equal to the numerator of the equation in the standard form. So it's 3 over 2. We know that e is 1, so that means d times 1 equals 3 over 2, which makes d equals 3 over 2. But because the equation it's in the form 1 minus sine of theta, then the directrix, it's y equals negative 3 over 2. Part 3. Let's write the equation in a rectangular form. So right now, r equals 3 over 2 minus 2 sine theta is written in polar form. So I started with the equation, the original equation, without changing it into a standard form. So what I'm going to do is multiply both sides by 2 minus 2 sine theta. So we get r times 2 minus 2 sine theta equals 3. Open up the parentheses, so 2r minus 2r sine theta equals 3, which means 2r minus this quantity here, it's y, so minus 2y equals 3. I'm going to move the y on the other side, so 2r equals 2y plus 3. I'm going to square both sides, so we get 4r squared equals 2y plus 3 squared. 4r squared equals, here we use the formula a plus b squared, which is a squared plus 2ab plus b squared. So we get 4y squared plus 12y plus 9. We also know that r squared is x squared plus y squared. So 4x squared plus 4y squared equals 4y squared plus 12y plus 9. 4y squared cancels with 4y squared, and we end up with 4x squared equals 12y plus 9. Or if we divide by 4, we can say x squared equals 3y plus 9 over 4. So this is the equation in rectangular form. So this is rectangular form, and the original one, r equals 3 over 2 minus 2 sine theta, it's the polar form. All right. Let's do something else. Let's graph it. So I'm going to graph it using the equation x squared equals 3y plus 9 over 4. So let's make a table, x and y, and let's make a coordinate plane. So x, y. If y is 0, we get x squared equals 9 over 4, which means x equals plus minus 3 over 2. Don't forget, there are two numbers there. So negative 3 over 2 produces 0 for y, and positive 3 over 2 produces 0 for y. If x equals 0, we get 3y plus 9 over 4 equals 0, which means y equals negative 3 over 4. So if x is 0, we get negative 3 over 4. So let's plot the points. Negative 3 over 2. Let's say this is negative 3 over 4, and this would be negative 3 over 2, and this would be 3 over 4, and this would be 3 over 2. And then negative 3 over 4, and negative 3 over 2. So 0, negative 3 over 4, that's the vertex. And these are the symmetrical points. So the graph looks like this. This is the graph of the parabola. Also, we found out in part, in part 2, that y equals negative 3 over 2 is the directrix. So I could draw here the directrix. And 5, check the graph with a graphing utility. So let's open the calculator, and I'm going to graph our original function, the one that it's in polar coordinates. So we go to y equals, and now I'm going to write 3 divided by parentheses 2 minus 2 sine theta, close the parentheses, and then press graph. Well, we cannot see much of the graph, so I'm going to press zoom 0. And so I still think we cannot see much, so I'm going to go to window. Actually go zoom 6, because zoom 0 didn't help us much. But if we go zoom 6, we can see how the two graphs look similar. Also, we can do 6. We can find the focus. And since this is the directrix, the focus is symmetrical. So the focus, it's of coordinates 0, 0, because the focus is right here. It's symmetrical with the graph from the directrix.